my name is Kirsten Parrish, and welcome to our Science Inquiry Center focusing on light today. We're going to be exploring the properties of light and how cool light is and what it is, actually. And so, first of all, the student will come up and they'll be, ooh, so many colors, be excited by what they see. Here we have a light wave, which we'll talk about in one of the activities, with its parts labeled to attract interest. And also, we have our Roy G. Biv over here for students that may not be as familiar with what the acronym means. And so students, when they come up, they'll immediately see what to do. Okay, what do I do at this Inquiry Center? First of all, my first activity, and they're numbered 1, 2, 3, or 4, each activity card has a procedure and investigation questions. Because as we see, calling all explorers. We want explorers over here in the Inquiry Center. So my first activity, student will come up and they'll look at these directions. Following them, we're going to look at light waves. And so, number 1, touch the water in the dish with your finger and observe what happens. The student should be focusing on waves. They should make the connection that we're talking about waves. Also, by putting a wooden block in here, we see how waves react to an object. Do they try to pass through it, or do they bounce off and go somewhere else? So after a student observes this and plays with it a little while, maybe with 2 fingers, how do waves intersect each other? They'll look down here to our investigation questions and try to answer them and see what we see. For example, number 3, do waves pass through each other? Number 5, what happens when you tap the water harder or softer, or fast or slow? With those last 2 questions, when we tap the water harder, we're messing with the amplitude. We're making the waves bigger. Number 6, whenever we tap the water fast or slow, we're increasing frequency, which is messing with the wavelength. Basically, how many waves can we get in a second? That's what we're talking about. So moving on from activity 1, where we talk about light waves, we're going to play with sunlight or a flashlight. You can use a flashlight for this activity, but it'll take a little bit longer. So activity 2 is a student will use sunlight, and I know it's dying here, but from a window or another source, and they're going to focus the light from the sun onto the piece of paper and adjust it close or far away, depending on where the light is, to get a small, intense little dot, and then observe what happens to the paper. Looking at our questions, for example, number 2, what kind of energy struck the paper? Number 3, what kind of energy are we usually talking about when we mention burning? So number 2, the answer to that question would be light. Light struck the paper, but when we talk about burning, we're usually talking about heat energy. So this is summed up in the 4th point, I guess. What could you say about the energy that changed the paper? Well, light energy was converted into heat energy, as we can experiment with in this experiment. So that's talking about how light and heat energy are related. Activity 3, moving on to our nice brightly orange colored paper, we're talking about prisms. So in this experiment, the student will either, they'll have to find a buddy to hold up the hold up the white cardstock, or you could prop it up against here, I guess. Using our flashlight, we're going to be talking about what is white light. If we have so many colors, if we have Roy G. Biv, why is light white instead of different colors? Passing it through our prism, we will be able to see a variety of colors, and it might take a little bit of time to get it the way you want it. There we go. You can see it a little bit, that rainbow colored right there, how the prism is breaking up the white light into red, orange, green, blue, and red, orange, yellow, green, blue, and violet. And so we can say that, what can we say about white light? Well, white light is really made up of all the colors. and that it takes a special device like a prism or something else to separate that white light into its colors so we can see. And this is kind of getting the student thinking about white light and that it's made up of all the colors meshed together. So that's activity number 3. And our last activity is talking about reflectors. So in this experiment, we're going to use our flashlight again, but we'll be shining, my lovely assistant holding the camera is going to darken the room for me. Your patience is appreciated. Okay, so the student will take her torch and using our smooth piece of aluminum foil, shine the light off of it and see what happens. Seeing how, well, we can see it better over here. So, you see the reflection. Light reflects off this smooth surface. Then we move on to testing other pieces of paper, like the rough foil, which doesn't reflect nearly as well, and white light, purple light, purple white light, white paper and purple paper, and also using the dark black or brown side of the clipboard, which doesn't reflect much at all. The reason I turned out the lights is so that you could see it reflect on the ceiling, but if that's not possible, you can use another surface. It's just better whenever it's in a dark room. So in this activity, the student is playing with how light reflects. What kind of objects, what kind of materials reflect light best? So for example, one of our investigation questions is, what could we say about dark and light colors? Thank you. What could we say about dark and light colors affecting reflectivity? That's a word. And what could we say about smooth and rough surfaces affecting the way light reflects? Well, light colors and smooth surfaces are going to reflect light more than rough or dark surfaces. So that's getting the student thinking about what reflects light best. So in our light investigation center, our science inquiry center, that's what we're talking about today, investigating the awesome qualities that surround us every day in light. Thank you.